How does metallography reveal microscopic crack propagation? Imagine trying to follow a tiny crack as it sneaks through a metal piece. How do scientists actually see these tiny cracks and understand how they grow? That's where metallography comes into play. It's a technique that lets us look at the very small features inside metals, like grains, phases, and defects, under powerful microscopes. When a metal breaks or shows signs of stress, metallography helps us see exactly how those cracks moved through the material. First, a small cross-section of the metal is carefully polished to make it smooth and shiny. This preparation is key because it allows us to see the microstructure clearly. Then, using optical microscopes or even electron microscopes, we can observe the crack paths at very high magnifications. These images reveal whether the crack traveled through the grains, along grain boundaries, or along phase interfaces. Cracks often follow the path of least resistance, which is usually along boundaries where the structure is weaker. For example, cracks might deflect sharply at twin boundaries where the crystal orientation changes. This deflection shows us that the crack is responding to the microstructural features. Metallography can also tell us whether cracks are growing through the grains themselves, called transgranular propagation, or along the grain boundaries, known as intergranular growth. The way a crack propagates depends on the local properties of the material, like how easily the grains slip or deform. Sometimes, we see tiny lines called fatigue striations on the fracture surface, which mark each incremental step of crack growth during cyclic loading. These lines help us estimate how fast the crack was growing and what kind of stress was involved. Advanced techniques like electron backscatter diffraction, or EBSD, can map how the grains are oriented and how that influences crack paths. This helps us understand why a crack might slow down, change direction, or speed up depending on the microstructure. When analyzing failures, metallography is essential because it links microscopic crack behavior to the larger failure. It helps identify the origin of the crack, whether it started from an inclusion, pore, or phase boundary, and how it grew over time. This knowledge guides improvements in material processing and design to prevent future failures. In short, metallography reveals microscopic crack propagation by showing us the crack's path relative to the microstructure, identifying the growth mode, and connecting these observations to how the material behaves under stress. It's a vital tool in failure analysis, helping us understand how and why cracks develop and spread in metals.